Hello, I am Shan, a PhD student at Australian National University and Data 61 CSIRO. I will be presenting our paper titled View from Above, Orthogonal View-Aware Cross-View Localization. Firstly, I will explain the motivation of our work. Existing geometry alignment-based methods, employing techniques like polar transformations or planar homography, focus on establishing correspondences for on-ground clues. This often results in neglecting important landmarks on the road, leading to a lack of robustness in scenarios like road mark fading. Here is an example. Geometry alignment using ground plane homography constructs correspondences between the aerial view and ground view at the root of the streetlight in the bottom green box and the road edge in the bottom red box. However, the appearance between the aerial view and ground view aligns better at the top of the streetlight and the treetop. To improve appearance matching, we propose a top-to-ground aggregation module that aggregates features down to the ground level. This paper proposes 3 novel components to the geometry alignment pipeline. 1. Top-to-ground feature aggregation. 2. Cycle domain adaptation, loss. 3. Equidistant reprojection loss. The top-to-ground feature aggregation uses a transformation mechanism. First, we visualize the line-wise attention map. Query pixels are positioned in a line progressing toward the bottom, while reference pixels are located directly above each query pixel. Yellow represents high attention, and dark blue represents low attention. On the road side, high attention is focused on the tops of walls and leaves, indicating that they substitute the information below for improved alignment with the view from above. High attention is concentrated on the query pixels themselves or on the nearby on-ground pixels above, on the road surface, which are already well aligned with the view from above. From the confidence map with and without T2GA, we can see that with T2GA, high confidence values are assigned not only to road markers, but also to landmarks like traffic poles and guardrails. In addition to the varying appearances of the same object across different views, factors such as camera tone, hue, intensity, brightness, resolution, and temporal changes can lead to inconsistent representations for the same geographic location. We propose a cycle domain adaptation loss to explicitly enforce view invariant representations. This involves an L2 loss between ground and satellite feature representations in 3 different feature spaces. Additionally, we use the focal lengths of the satellite camera and the vehicle camera as conditions in the encoder and decoder to aid in pixel-wise feature alignment. Our method addresses the challenge of simultaneously detecting key points and predicting vehicle pose. Common reprojection loss overly penalizes orientation errors of distant points, causing detected points to cluster near the vehicle and reducing orientation accuracy. We propose an equidistant reprojection loss that normalizes the reprojection distance by the point-to-vehicle distance. As shown in the figure, our method detects points farther from the vehicle. Finally, I'll introduce our experiments. The table compares our method with existing methods under initial noise conditions within plus or minus 45 degrees and plus or minus 20 meters. Our method outperforms existing methods in all settings. Here is a comparison of the baseline method and our method under varying initial noise ranges. The blue bar indicates the median value, while the red bar shows the difference between the median and mean values. Notably, our method demonstrates robust convergence. We further adopt accumulated pose estimation. Our method consistently achieves accurate pose estimation even in challenging scenarios with limited localization cues or severe occlusions. Existing methods exhibit significant drift, often drifting out of the range of the satellite image and causing progress to stop. The figure showcases that existing methods fail in occlusion cases, such as when the road is covered by tree canopies. Our method is the only one that successfully completes all test route. Thank you for listening.